Hey everybody, I hope you all had a great weekend. Um, Mine was pretty good. A bit busy, but I still had some time to work on some projects and just relax, so it was nice. Let me see. I think, oh, I did have a little bit of time to work on this project just because I kind of wanted to I want to move on from working on terrain all the time. So I did a little bit on the normal generation. And you can see, if you look closely, these bands of colors, and since these faces aren't all one color, that means that we are getting some different normals here. So, yay, some progress. And if I open up, just look at these meshes in the editor and then add the tangent space visualizer, which will display normals, we can see that yes, they are changing a bit. For example, yeah, so here, obviously, they're not all pointing the same direction. It's a little hard to tell because it's hard to see which vertex belongs to which shape, but eventually we'll want all of these points to kind of converge and all point in the same direction. And these three are all really close because these rectangles average with a hexagon and the hexagon averages with both rectangles. So this one that's in the middle here I think is from the hexagon, and then the two on either side are from the rectangles, and then the one that's sticking out like that, this is a triangle because the triangle is not set up to merge with anything yet. So yeah, we'll need to get that working soon. But yeah, I'm glad to see some progress. So we ended the stream last week with a little bit of, I guess, a realization that the twin maps can be generated on the section templates, and a template is basically data that's the same for every terrain section that's the same type. So a hexagon face has one template. Another data we can have like that are the triangles, because the triangles are the same for every hexagon really, and also the arrangement of points. So then we can add twin point maps to that as well. And the reason that we need to know the twin point maps is because we know that there's 4 points here, but the game really has no way to tell which points have the same position without looping through everyone and seeing if their positions are equal. That's really slow, so... And since I know the arrangement of points, I just have to program in a way for the game to just know that these points are twins. And once we know that, we can look through all the triangles that contain that twin point in the neighbor and add that triangle's face to the normal calculation. So I have twin points between the hexagon and the rectangle complete, but now I need to do rectangle and rectangle, and triangle and hexagon, and triangle and rectangle. So we don't need triangle and triangle because they never will touch. Also here I realized before, I noticed that some of the rectangles are flipped with regards to the hexagon because they start... okay, well, let me open up the game again. So basically, okay, so for this one, this rectangle is parented to this hexagon, and so it starts here and then builds out that way. And so this is 0.0 here, but over here, this is actually the last point in the hexagon, so they're kind of mirrored. And before, I used to figure that out by checking the parents and then seeing if they were equal or not. But I realized that's not really needed because we know we can tell which parent a hexagon has just by what side it is on our hexagon. Because, let me open up this. Yeah, so here, every hexagon, we just create sides 0, 1, and 2, and triangles 0 and 1, which correspond to 0, 1, 2, and 0 and 1. And doing that, we actually tile the entire map. So we know that sides 0, 1, and 2 always have us as their parent, where sides 4, 5, and 6 have something else as our parent, and then same with the triangles. So I was able to cut down on the number of twin maps I actually needed, because I used to generate one for every side and then every orientation, but now I just need one for every side, so that helps a bit. So I'm going to do the same thing with the triangles, but I think to help me visualize it, I'll make a new little diagram. We've got a ton of little helpful things in here. I don't really know what this was trying to be, but I'll leave it. So basically, it's going to be a bit hard. Trying to think the best way to do this. Okay, and I think I'll scale it down just to make things a little easier for me. Okay, and I'll remove these points. I guess I really could just add this to this diagram. Because, yeah, I don't even use this style of triangles anymore. So yeah, so this is point our hexagon 1, and it would grow. Okay, I don't really know an easy way. Okay, let's just do this. Where does it look good? I just want to make a arrow. Yeah, it's that way. Let's do. Okay, that's kind of strange. Oh, okay, I had to. Okay, well, that looks good actually. Okay, it doesn't need to be perfect, but. Okay, so yeah, it grows that way. Similarly, this triangle. Well, that's not actually true. Because I think the x-axis for triangles grows like this, and then, oops, the z-axis is along that way. Okay, what am I trying to do here? I just want to have a visualization of each of these shapes so that I can see the arrangement of the points with relationship to another. So I guess first I'll just fill in these holes. I don't really have to have it be perfect, but I don't know, I just feel like it. Also, you might be wondering, what about if we're at the edge of the map, then this side would not be created. That's okay, because, yeah, like I said before, the map border will probably be handled differently, and I'll have to decide when that time comes how I'll deal with that. Okay, so I guess the question is, how do I want to make it clear where the X and the Y axes are? Because that would explain how these points grow. Oh, okay, so can I put a little arrow on the end? That'd be kind of nice. Oh, okay, you can't do that. Okay, so that's the way the X grows, except it's a little big. Okay, that's better. Okay, and then for this one, X is the same. Okay. But for here, X actually goes this way. Because they always go clockwise around the parent. Okay, so for all of these, I just need to copy the style. Okay, so I think I can select them all. And just give it that little arrow. Oh, is this all one? Okay, that's not gonna do. I can just delete that, and then I guess I'll need to draw anew. Okay, so now their z-axis is pretty simple as well. Okay, let's deselect that. And they just grow that way. Well, it doesn't really matter where I put the start point. Do I want to just... Maybe they should start at the origin. I guess that'd make more sense. Okay, and then these actually go towards us, which is the main problem, or not the problem, but the main difference. Let's color these purple, I guess. Okay. Okay. Maybe I should make them... Let's actually make them all like bluish to go with the blue rectangle. I just realized that's probably a good idea. Oh, I know I just selected all of them, but I actually want to get the actual color I used. Oh, that's weird that the arrow is not changing right away. Okay, so I'll make the X lighter, and then the Z will be darker. Okay, I know I'm spending quite a lot of time on this diagram, but I think it's gonna help me a lot when I'm trying to figure out the arrangement of points. Okay, so if I refresh... Oh, it's still... Okay, well these little arrowheads are a little buggy, but at least they get the job done. They seem not to update. When you batch change them, you have to click on them again. Okay, so that's the rectangles. We already have that pretty much taken care of. Triangles. Okay, and this is going to be a little awkward because they're in the same spot, but I think I'll just move this, or move one of them over a bit. Okay, well, actually that's wrong. The triangle, the x-axis goes to there because it starts on ours and then goes to our counterclockwise neighbor. Okay, so let's I guess I'll go ahead and do it from the right color right away. Or do it in the right color. It's a bit hard to see. Okay, so yeah, oops, that's not what I wanted to do. Let's move this a little bit over so I can see the triangle. And it doesn't really matter really where it's placed. In fact, I think I'll just go ahead and do that with all of these. Oops, I guess I should turn off snapping. Alright, so that's the x-axis. And then the z-axis goes like that. This won't be perfect, but it will get the job done. Okay, I still think this color is a little too hard to see. Guess I'll just make it more yellow. Okay, so I'll grab this and now I'll just draw the rest of them. So, okay, it's the same for this triangle. Now for this triangle, its parent is this one. And it goes to its counterclockwise neighbor, which is us. So it would go like that. And this parent, or this triangle, its parent is this one. And so it goes towards us. Same here, except that goes towards that one. And then here, yeah, it goes counterclockwise. So let me make sure I did that right. It always goes counterclockwise from the point it starts. So there, 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 and there. Okay. Okay. Yeah, this color is not good. It's too hard to see. Okay, that's better. And now the arrowheads aren't going to update until I click on them all, because they're kind of bugged. Alright, so now the z-axis, it always just starts and then goes to the last point. So I don't really... Well, it might be needed at some point, so I'll just go ahead and draw them. But I think the x-axis is really the more important thing. Okay. So another thing to know is that the points in the triangle also wind along this way first. So that will be important as well. Okay. So now we've gotten that all taken care of. Hey X Squirt, I'm doing pretty good. Just a little, well, it's Monday, but I had a nice weekend, so I can't complain too much. How about you? Alright. So I think I'm ready to start doing some math now. Now I had thought that, okay, so I'm trying to do a hexatriangle. I guess that's fine. So I thought I could handle side 0, 1, 2, 3, and 4, 5 the same way, but let me actually see if that's true. So here we know this point is the same as the triangle's origin point, which is number 1. Yeah, that's the same. So really, we just need to see like what... Excuse me. Sorry, something caught in my throat. Yeah, Monday. So the main thing is we've got to see which point on the triangle corresponds to our point on the hexagon when we're trying to find the quote twinned points. And okay, so we can use this yellow arrow kind of as a guide. So for these two, it's the start of the arrow that's on our hexagon, and for these two, it's the end of the arrow. And then for these two, it's the one that's not on the arrow. So, okay, I think I was right that I can treat point 0 and 1 the same, and 2, 3, and 4, 5. So let me go... keeps confusing me. Sometimes it doesn't show the little application icon, which makes it me always miss the screen. Um, how's my family doing? Not too bad. Well, I mean, I don't want to talk about it too much here, but we're making it through. And yeah, I'm glad that you did stop by. I hope that you're all doing well too. Or best you can, anyway. It couldn't give me a headache. Well, yeah, especially when I have to do all this geometry. There's so much math. Like, I was trying to do it without drawing these diagrams, but it's pretty much impossible to wrap my head around. Okay, okay, so I guess I'll start on the hexagon. Well, so what I did here is I had a function that generates the twin map between the hexagon and rectangle margin, and then for rectangles I just kind of flip it. So I guess I'll do the same thing. Okay, I'm glad to hear that. How do I want to encode this? I guess I'll just have an integer which will tell me shared triangle point. What game is this coding for? Okay, well it's still working. I wasn't sure if what I just did would make it not runnable, but it's kind of I'm sure you've heard of Pokemon and maybe Fire Emblem, but it's kind of like my idea is that it's kind of a mix of like Pokemon team building, but then on a 2D like chessboard type thing. And I've been working on trying to get the graphics to look better, specifically the terrain. But yeah, the monsters can kind of move around. They can't really attack each other right now. But one thing I'm pretty proud of is so far I have like working online multiplayer, and it will be moddable, so you can add in your own monsters and terrain types and attacks and things like that. So I think it'll be fun once I finally get everything up and running. Thanks, yeah, I'm pretty proud of it so far. Okay, so this is trying to find the first point. I guess I'll get rid of this just so it won't throw any errors on the hexagon, and it really just depends on what corner we're on, I think. But let me see, what's this doing? Oh yeah, so this is adding up all the points on rings before the final edge. And then this is telling the number of points on the final edge. Okay, I see. Oh yeah, because we have to loop around and all that. I think I can actually keep all this code. Does adding online require network code? Yeah, it does. And it was, well, I use Unity, which has like built-in networking, but unfortunately I couldn't really use most of its provided functions because it's for more like a real-time game. And since this game is turn-based, it didn't really adapt very well, so I ended up having to write a lot of it myself. But I think it will be well worth it. Okay, so this is trying to find the point on the triangle, and oh yeah, I don't even need to do, okay, I can simplify this because every hexagon only has one point in common with a triangle. So I don't need to do all this about looping. So yeah, I don't need that. So the hexagon start point, we still need to do this, I guess, and then we need to add the side offset. So let's see. Yeah, so that's it. I can even just rename this to hex point, because again, we don't loop. It gotta be monotonous. Well, yeah. I've been working on the terrain for a while, so that's why I tried to do a bit over the weekend to, I don't know, speed things up. Unfortunately, I couldn't finish the whole thing, but I hope that I'll get to work on some art. If not today, definitely tomorrow. Okay, so the triangle point, let me see. Okay, well, the center of the triangle is always 0.0. And then we just loop around. And there's, what is, this is actually the rectangle margin number. Okay, so how many points are on a triangle side? Well, I guess if you... Well, there's 1 point per margin subdivision, so... Okay, so we can just do 1 plus database metrics. And then we have to add 1 for the corner points. Times the... Oops. This shared triangle point that's passed in. Let me rename this to shared triangle corner. I think that makes a little more sense. Okay, so then we will just register those 2 points as being a twin. So let's test this right away. So I need to make hex for a twin map. Yeah, I guess I gotta do it for every corner. Oops. And then the shared triangle corner. Okay, I don't think this will be too difficult to do. So for here, okay, if we say this is corner 0, 1, and 2, so 0, 0, 1, 1, 2, 2. Okay, so that's actually pretty simple. That's just C divided by 2. Oops, keep pressing the wrong key. Alright, and then I just gotta register the twin map to a triangle. And I don't have to give it anything else besides the corner. Alright, so we're not gonna actually use the twin map yet, but I just want to see if it actually makes sense. Okay, so templates. This is a hexagon. So okay, this is for the rectangle. Oh, that was a triangle. Yeah, side 0, and then okay, it says 0.1 for each, and I think that is right. I go here. So the center of the hexagon is 0.0, and then this is 0.1, and it goes around clockwise. Similarly, for a triangle, the center is 0.0, and then it starts at its parent hexagon, which is S, since we're at 0.0. So this is 1. So that's why, okay, so 0.1 for hexagon is in the same position as 0.1 for a triangle. And that's what it's telling me here, so that is correct. And then here, this is 0.2, same thing. Let me see. So this is the second side, and it's saying hexagon 0.3 is 0, 1, 2, 3, and then triangle 0.2. So this one, the parent is below it. So 0, 1, 2. So that's right. Okay, so I guess every odd element is a triangle. That's the one I just checked. Okay, so this is side 3, which is here. And the parent is this one, so 0, 1, 2. And then the hexagon point is 4, so 0, 1, 2, 3, 4. Okay, so that is good. And here, the parent is this one, 0, 1, 2, oh wait, 0, 1, 2, 3. And 0, 1, 2, 3, 4, 5. So that's right. And the last one. Yes, there's a lot of counting in this. Alright, so hexagon point 6, 0, 1, 2, 3, 4, 5, 6, and triangle point 3, 0, 1, 2, 3. So I think we're all good. So I gotta do, before I can actually start averaging the normal vectors, I need to do the opposite for the triangles, and it's pretty simple. I just need to make a new function here to run for a triangle margin, and then make hex to triangle twin map. Okay, so I need to make one for every, oops, should copy this. For every hexagon side. It's not for each of my triangle sides. Because this is, well, the twin map changes based on what hexagon side that we're oriented at, not at our triangle, if that makes sense. Okay, and then here I need to flip the twins because I'm just using the same function, which gives me twins from hexagon to the triangle, but I want this to encode from triangle to the hexagon. And so now I just need to add this so it will actually call that function. And I'll just do one more quick check here. I don't think I won't need to go around and count everything again because it's using the same function, but I just want to see that the data is actually in there. Okay, so spanning triangle margin has 6 twin maps. That's one for every hexagon side. Yeah, and it looks like it's good. So these are basically exactly the opposite of the ones that I just counted up. So I'm just gonna assume that there's no bugs there. Alright, so now I need to go to this code which picks out the correct twin map to use for every edge of the hexagon. And I think I can do something like this. Okay, so we're saying here that we want to get a twin map from the triangle margin that maps to a hexagon face, and we're gonna go based on is that right? Why is it doing the parent side? Oh yeah, because a hexagon doesn't have a side associated with it, it's the margin, so this is right. So I think that works, and then down here I do the same thing for a triangle. Okay, I remember I had this like fancy little function here. I don't know if I'll still be able to use it. So for this I need to, I want to find a twin map on the hexagon to a triangle. And I guess I need to use the side on the hexagon here. Okay, so this function has some unneeded information now, because used to I would store these in an array, but I don't even have to do that anymore, so I'll just delete those 2 arguments. Okay, so now I think the game should find those twin points and average them together. Or average the normal vectors together. So here, okay, I can see it's doing a little bit because the lighting on the triangle is a gradient instead of being a flat color. So the normal vectors have to be changing. We can actually test that for sure. Oops. We'll add this and it will visualize the normal vectors for me. Okay, well they're still not perfect because obviously the triangles don't average with rectangles yet. But we can see that the points are getting closer together. That's interesting. This one's still pretty far out. I thought that it would be brought more towards vertical. So I know that it is averaging a bit. Actually, now that I think about it. Oh, you know what? I did the calculation slightly wrong. Every triangle has more than 3 points. Okay, because I was gonna say, I don't think... Okay, I shouldn't have closed the game, but that's okay, I'll just add this back. Okay, X Squared, yeah, thanks for stopping by. Hope good luck on Fortnite. Okay, so the reason I know that I realized there's an error here is because these points are being averaged when I haven't set up triangle to rectangle averaging yet, so this point should not have been affected. So obviously I got the offsets wrong. And the reason I did that is because I had forgotten that we have these extra points here even when the margin subdivisions are set to 0. So what I need to do, I think I made a silly mistake because yeah, this even tells me the number of points on an edge, so I don't need to calculate it myself again. Well, it's not that big of a deal to fix. It's just I think this number is wrong. So I need to instead, oh, that's a rectangle. Okay, so I just need to look into the triangle template at the arranged data. And I should subtract 1 because I think this includes both endpoints, but we don't need to do that. We just want to include one endpoint. Okay, so let me load this up again. And okay, so this looks a bit more sense. This makes a bit more sense the way that the lighting is being blended here, because only these points that touch a hexagon should be changed, so everything else is just pointing straight out from the triangle. And again, I can visualize this by adding that script. Okay, so now this is right. These points are all starting to get closer and closer together. Well, these points are still really far apart because the triangle doesn't average with rectangles yet. Oh, that was funny. His head's floating. Alright, so I think I don't see anything else weird. Let me check a couple more triangles to make sure everything is still okay. Alright. So this is all good. So now I'm going to do rectangle to rectangle, because you might think that rectangles don't actually touch, but we can see here that they do have a point in common, so we do need to average between them. And I'm trying to see which points will have the same pattern, I guess. So I really need to look at the orientation of these arrows and see which ones are the same. So points 0 to 1 is both end of the arrows touch, I guess. And okay, so 0 to 1 and 1 to 2 is like that. Okay, how should I keep track of this? Okay, I guess I'll just write it down here. So I think we're gonna have 3 different or I think unfortunately each of these rectangles is gonna have kind of a different pattern, because both sides I think might be in a different situation for every side. Or that was confusing. Each of these rectangles, if you go to the clockwise and, or sorry, I did that backwards, the clockwise and counterclockwise neighbors, there's going to be a different situation for each of them. So I'm going to try to do that here. So the counterclockwise, I guess I'll label this point 0, 1, 2, and 3. That's not really correct, but it will just help me figure this out. So the twin is 0 to 2, And then clockwise, the twin is 1 to 0. So here we see our point 0 is twinned with our counterclockwise neighbor's point 2, because it goes 0, 1, 2. And you can kind of see what it is based on how these arrows are pointing, which is the whole reason I decided to draw them. Okay, and then for point 1, this is going to be a little annoying. I want to keep it all on one monitor. So point 1, our counterclockwise neighbor is our point 1 goes, or our point 0 goes to their point 1. And clockwise is actually the same as before. Our point 1 goes to their point 0. Having trouble drawing these arrows. Okay, and so side 2, counterclockwise is our point 0 is their 1. And clockwise, okay, so this time it's actually their point 0 because 0, 1, 2, 3 are their point 3. I said that backwards. Is my point 1 is their point 3 are twins. Okay, and side 3. Okay, so this time, I guess I'll go like that. Our twin is, okay, so this is counterclockwise. Yeah, because we're doing it with respect. Oh wait, no, this is counterclockwise because I'm doing it with respect to this center hexagon. So it's my point 3 is twinned with their point 1. And clockwise, my point 2 is twinned with their point 3 because it's, yeah, 3 is the one that doesn't have any arrow points associated with it. Okay, and side 4, my point 3 is twinned with their point 2, and my point 2 is twinned with their point 3. And finally, the last one. My point 3 is twinned with their point 2, and oops, I've forgotten the colon on all these. I guess it doesn't really matter. And my point 2 is twinned with their point 0. So again, we can see where these touch. Obviously, they're just flipped. You can kind of see the precession here. So 0, 2, and then 1, 0. It's the same as 0, 1. And then 1, 0 is the same as 0, 1. 1, 3, same as 3, 1. Yeah, so they're just flipped like that. I wonder if I can use that to my advantage. I don't really see a simple pattern here, though. Like 1, 0, 1, 0, 1, 3, 2, 3, 2, 3, 2, 0. Well, that is a little interesting. Or I could do it like this, where sides 0 through 2 are 0, sides 4 and are 3 through 5 are 3, and then it's 1, 1, 1, and then 2, 2, 2. Just offset like that. That might be the way to go, actually. And then these are obviously just flipped of the... Or are they? Okay. Yeah, these are flipped of the next one in line. So maybe these should be... I guess it doesn't really matter that much. Okay, I think I'll copy this and I'll actually save this in the code because I'll probably use this or this pattern to program this. That's messy. Okay, I don't know why it's doing that way, but So obviously I can't use these numbers directly because these aren't the actual point indexes, but these are more like the corners. So this is rect to rect twin map. Okay, so it's important that I... Okay, let me start this. This will be the clockwise side. Or... Okay, I'll call this the start side, and then we'll always move counterclockwise, or we'll always move clockwise. And so the counterclockwise will just be the same thing flipped, I think. Okay, well, yeah, that would work actually. So to do the counterclockwise, I would just send... Okay, well, let's actually... Before I make this function, let's do the code here. So, okay. Every rectangle has two twins. And the clockwise one will just be make rect to rect twin map. And then we'll add a twin map. Okay, so here we'll actually need to pass if we're doing the clockwise or counterclockwise neighbor. So I don't know, do I want to actually use that orientation enumeration or just pass another? Oh, well, I guess we can, I don't know. Yes, this is what I'm looking for. Okay, so I won't use that anymore. I guess I'll just do clockwise and counterclockwise. Okay, so this one is the clockwise neighbor. Okay, and then for the counterclockwise one, I just need to get the corner before this, which is the same as adding 5 and then modulo 6. And again, I did this, explained this before. So you can't just, it's not a good idea to just subtract and then loop, because if you go below 1, it doesn't work how you'd expect. It would return -1 instead of looping around to 5. So what you have to do is you subtract 1 and then you just add 6. But when you mod 6, it's the same as just not even adding this, so you can just put that together to add 5, and that will give you the corner before. So I hope that makes sense. It's basically the same as doing C-1, but we have to do this modulo math so that 0 will loop around, or 6 will loop around to 0, and for example. So that's giving me my counterclockwise neighbor, which is the corner before this. And then I need to flip that because I want it with respect to me, and then I can just add a twin map to my corner, except this will be counterclockwise. Okay, I think that's fine. I mean, there's not really a reason. Well, I guess I'll leave it that way. I was just thinking there's not really a reason to store these twice, because I can kind of just use this one and then flip it in the code later. But I don't think that's how the normal generation system works, so I'd rather just keep it working like this. Okay, but anyway, let's see. So I need this point recession. Okay, so I'm gonna actually even... I'm gonna add clockwise in there right there to make it very clear. So we want to find 1, 1, 1, 2, 2, 2, and then this as well. And then for the counterclockwise, let me just make sure this works. Okay, so what we do, this would return basically this mapping. And then for counterclockwise, we'd want to return this mapping. So what we'd actually do is subtract the side before us, which is 5, and then we'd get this and then flip it. Okay, and that is correct. Alright, so... Okay, but we need to find the actual point instead of just the corners. Okay, so I guess first we'll get the corner. My corner is... Well, it's either 1 or 2. So start side... Oops. Less than... Okay, the splitting point is at side 3. So if we're less than 3, it's 1. Otherwise, it's 2. And then the neighbor corner is start side. This one's a little bit more confusing. Because if it's side 0, 1, or 5, then we return 0. Otherwise, we return 3. So how is the best way? Okay, I don't think I'll try and do any fancy math here. So basically, if it's less than 2 or 5, we'll return 0. Otherwise, we'll return 3. We could do like some modulo stuff, but it's just going to make it more confusing. And I think I'll actually move that here to make sure that this is, or to make it obvious that that's what this is referring to. Okay, so now we have the corners. I need to change them into a side, and I think I'll make a separate function for that. Get rectangle corner point index. I don't really know if there's any fancy way to do this, so I think I'll just do a switch statement. So I know that at corner 0, the point is 0. 1. So here, oh yeah, this is void. If I look at our hex diagram. So here it's just, okay, so 1 plus the number of hexagon subdivisions, which is 2, so yeah, 1 plus 2 is 3, so that's right. Actually, before I do that, so the number of even point rows, and then the size of even point rows. Okay, so that makes it a little easier. So, okay, I know that the size of an even point, or of an even row, which row 0 is even, is given in here, so I can just subtract 1 to get the actual point index. Okay, and this point is probably the most complicated one. I've got to know, well, I can just get the total number of points and then subtract 1 row. It's probably the easiest way to deal with it. Okay. Okay, I'm putting an extra curly brace in here so that this variable stays local to this case block. So I'd return rect template dot number of points minus the size of an even row, which obviously the last row is even. Well, not obviously, but it is. I think that's correct. Okay, and then this one is really easy because it's just the very last point. Which is given by the number of points minus 1. And then there, I guess, okay, I have to have a default or it's going to complain. I'll just return -1 because that should never happen. So here I just need to add a twin, which is get rectangle corner point for my corner to the neighbor corner. Alright, so that turned out not to be as complicated as I thought. It's more complicated just figuring out all these numbers, but the algorithm is pretty simple. So before I actually add this to the normal generation, let's make sure the numbers make sense. Okay, well, no errors. That's a good sign. Yeah, so this has a lot more twin maps now because it has... Okay, so the spanning rectangle margins are... well, elements 1, 2, and I guess they skip one every 3 elements. Okay, so this is the side 0 and clockwise. So it's saying my point 1 goes to their point 0. That is actually correct. I was gonna say I think that's wrong, but right now we don't have any extra points on here because there's no hexagon subdivision, so... Okay, let's look. This is side 0, so... This is rectangle point 1, and then this is their rectangle 0. And counterclockwise, remember it's growing that way, and we can count the points. 0, 1, 2, 3, 4, 5, 6. And it's my point 0, which is here, is their point 5, so that's right. Okay, so it seems like I really want to go through and count all these. Let's just check a couple more. So this is side 5, which is here. And it's saying my 5 is 0. That's just the flip of what we just checked. And then my side 6 is their 5, which is right. 0, 1, 2, 3, 4, 5. Let's try side 4 because that one's a little different. That's right here, actually. Okay, so it's saying my side 5 is their side 6, so... Yeah, that's right. 0, 1, 2, 3, 4, 5, 6, and 0, 1, 2, 3, 4, 5. And then here, 6 to 5. Yeah, so here... 0, 1, 2, 3, 4, 5. Yeah, so I think it's all good. Okay, so now here I just need to add in... Okay, so this point is where it's checking... Okay, that's a triangle. So yeah, so here it says if my parent side is equal... Or wait, if my side is equal to their side... wait. Okay, so this is the clockwise side. Or... Sorry, I said it backwards again. The counterclockwise side, because we're subtracting 1. So yeah, it's basically checking if this is our counterclockwise neighbor. Then I can just add an entry here. So I want to go from rectangle margin to rectangle margin, then my side, and pass counterclockwise here. And then similarly, right here it's checking if they're the next in line, which would be the clockwise neighbor. So rectangle to rectangle, my side and then clockwise. And I think there's something... Okay, so here is my other two neighbors. Do I have other two neighbors? I don't, I just have two. I don't know why I thought I had other ones. Oh, I do have these neighbors right here. So that's a whole nother thing I hadn't thought of. Do I need to... Well, I can kind of... Okay, I can use the same twin map. I just need to shift over to this hexagon. Maybe I do that already. Okay, so it's neighbor. So yeah, it's my side on the neighbor. I think I can just shift over. Okay, so it's not rectangle to rectangle, and then this is side on neighbor. And yeah, this will be counterclockwise. And then I want the same thing. Okay, so this I think will work. I guess I should check logically to make sure. Yeah, that's clockwise except one side on neighbor. Okay, so let's take... I guess this point works fine. So 0, 1, 2, 3. So here, we know these work. So basically, this neighbor is the same as being side 5 here. Which is, we can see it's the same, so I can actually shift this up. Yeah, so it's exactly... Yeah, because our actual parent doesn't matter, it's just our relation to the other rectangles, so... Yeah, there's nothing different. Okay, no errors again, that's a good sign. So I don't think there's going to be any drastic changes here. Although we can see a little bit of gradient coming from the corner. Except these should be... Okay, that's kind of interesting. I was thinking that the normals would be even closer to the same. Or be even closer to converging. I guess they are here. Maybe the triangle just has that... The center triangle has that big of an influence on it that they're not converging just yet. I don't see anything like super weird happening. It's going to be difficult to test this though. I might have to... I just wish... Yeah, there needs to be... Oops, that was weird. Like I should maybe extend this normal visualizer to somehow color code based on what section of the terrain. That'll be kind of a pain though. But let's not worry about it too much right now because they're not going to be completely converged yet because they don't take the triangles to rectangles. Twins into account. Let me see. Why did I... Oh yeah, I wanted to check one other thing before I move on. So if I go back in here and look at the actual sections, I'd like to find a rectangle margin and check out its neighbors. So this is this rectangle. Okay, that's a bit Okay, that tells me there's a bug here because this should always be pointing straight upwards. There's no variance in height here. This one is fine though. And even this one is like out to the side. I don't even know how that could happen. Unless they're somehow getting this. Yeah, they must be getting this rectangle as a neighbor. Okay, well let's see. So it says it has section 00, and that's the hexagon, and then section 02, which is this rectangle. And it's saying to use twin map 1 for that. So let me close this. Right, so yeah, 02, twin map 1. Okay, which is saying my side clockwise. Yeah, point. Yeah, so that's not the issue. And then section 19, which I think is the other hexagon, but yeah, so that's fine. And then section 23, which is this cell, side 0, 1, 2. And it's saying to use twin map 11. Okay, so side 3, 0, 1, 2, 3, counterclockwise, which is over here. So it's saying this element 6. That's backwards though. Yeah, that says okay. Because this, it should be going from this hexagon to this one. So it should be side 0, 1, 2. I must have got it backwards. Oh, I know what I did wrong. Okay, so here, yeah, I'm using my side when I actually need to use the neighbor's side. Okay, so it's kind of annoying that I have to calculate this twice, but I could store it all at the beginning. I probably should. Okay, so this will be counterclockwise, neighbor. I might need this for triangles too anyway, so I don't know. Actually, I don't think so, but... And then clockwise, neighbor. Okay, because I was using, yeah, my side when I should have been using the neighbors because I'm trying to find the map from the neighbor to me, so that's actually a good point. So here my counterclockwise neighbor actually needs the clockwise map because they're going to me. Is that true? So if I'm here, my counterclockwise neighbor is here. So yeah, they need the clockwise map. So it should be flipped. Okay, and then something similar here. Do I even need this side on neighbor? Oh yeah, I do for that. So let's do int counterclockwise on neighbor. Oops. Not supposed to have a negative sign there. And then clockwise on neighbor. Okay, and then again, I just need to flip these, I think. Let me see if that makes more sense. Yeah, that's a problem I keep running into is I keep on thinking I want to find the map from my section to the neighbor, but it's actually the other way around. I can't really tell much by the highlights. Okay, well this looks better right away because these are all standing straight up. Also, yeah, these... Okay, well this looks a lot better actually because we can see that they're all basically on this line. Which they should be because that means that we only need to kind of pull them towards the triangle. So when we add triangle averaging, hopefully that will take care of that. Let me just look at them and make sure there's not any that are like super lopsided. I think. Okay, well, these are pulled a little bit that way, but they might be anyway. Because there's like some elevation changes there. But in general, I think it's all working. I guess I should check to make sure that there's no problems switching to different chunks here. It's hard to see the green lines on that. I think that there is a part with a hill, yeah. Right on the chunk line. Okay, and this is still pretty much on this line here. Slightly to the side just because of the elevation. Okay, so I think I got that right. So I guess last thing I have to do is this rectangle to triangle. And I hope I can find a pattern for that as well. So really, again, it's going to be based on clockwise or counterclockwise. And I think I can, like this angle, I'll just kind of treat it, oh, it's the same as being down here. So, I think that will work fine. Let me actually see how the code deals with that. So we try to find a rectangle margin and make sure, yeah, we only want the counterclockwise parent on each of our corners. I guess I could do it that way, but what do I try to look at? So, okay, so for this side, we want the counterclockwise one. And then we go here, and we look at this, and we want the counterclockwise, and then here we want counterclockwise. Yeah, so that works okay. Although, well, I guess, okay, that's fine, because this is side 5, which should be identical to here. I'm just trying to see how many different orientations I need. Or how many different maps I need, I should say. Well, the rectangle needs one for each side, so I guess that will... And the triangle can probably just use all of those. Although it might not need them. Because I think the triangle only ever needs these sides. Let's check here. So this one is the same as that, and then this is the same as this. And then this one is the same as this. Yeah, okay. Well, yeah, that's fine. It doesn't really make much difference. Let me see here. I guess maybe the way to start off is again just to see if there's a pattern in the way that the corners proceed. Okay, so I'll do this based on the rectangle again. This will be counterclockwise. It's my side 0 to the triangle side 2. And then clockwise 1 to 0. Actually, how do I want to do this? Because now it's not just a point that we have in common, it's a whole side. So I should really number these sides. Well, really, okay, obviously for the rectangle, it's either the counterclockwise or the clockwise side, so I don't even really need to encode that. Although I guess the origin point does matter. Oops. Okay, now I'm just trying to figure out the right notation for this. Well, okay, I guess we'll always go in the rectangle's z direction. And then we'll just figure out if the triangle is in the same direction or not, and then which side. Okay, this will be confusing. So it's my, okay, I guess I have to do it like this. So 0 to 2 goes to triangle side 0, 1, 2, 2 to 0. And then clockwise is my side 1 to 3 to there 0 to 1. Alright, so I think I'll copy this so I don't have to copy and paste it every time. Or so I don't have to retype it every time. Never find the window. Okay, so again, this is mine. Well, I think the 0 to 2 and 2, 0 is actually, well, it's going to be flipped actually on the different sides. So, but yeah, 0, 2 goes to the triangle side 2, 0. Okay, so that's actually the same. And then this one is 0 to 2 goes to triangle 2, 0 again. Interesting. Well, that's actually different. So maybe we'll have another pattern like this. Okay, and then 0, 2 goes to triangle. Okay, this one's different. It says 0, 1. And then 1, 3 goes to triangle 2, 0. Oh wait, no, 2, 1 actually, because it's 2. Yeah, this is 0. Actually, I think I did this wrong, didn't I? Oh no, that's right. Yeah, 2, 0. Oh wait, no, that's 2, 1. Okay, now I'm confusing myself. Okay, so 0, 2. And 2, 0, because this is point 0. Obviously the arrowheads matter. And then this one is 1, 3 to 0, 1. And then 0, 2 to 2, 0. And 1, 3 to 2, 1 is this one. Okay, and then this is 0, 2, and 1, 0. So that's right. Oh, I got it backwards actually. And then 1, 3 is 2 and 1. 1, 0. Okay. My notation is not that good. I need to make sure that the order of these are the same. Okay, I did do that right. So that's 1, 0, and so this should be 1, 2. Okay, and then here we'll start this. Well, okay, this is actually the same as being up here, isn't it? So I don't really need to deal with this anymore. Well, yeah, side 3 is the same as side 0 in this case, but let me make sure. So, okay, well, this is counterclockwise, so... Okay, well, it's not actually the same because it's flipped. Because this one should go 0, 2, and also 0, 1. It's flipped on the local x-axis. Then clockwise is 0, or 1, 3. Oh, wait. Okay, counterclockwise is here. So this is actually 1 to 3. Okay, gotcha. This notation, yeah, I don't know. It's not that great. So when I think of it that way, these are the same actually. So 1, 3 to 0 to 1. 1, 3, 0, 1. But yeah, of course they're flipped. But maybe I can take advantage of that. And then, okay, so this is 0, 2. Goes to triangle point 0, 2. Which is the same as this one, which I expected. And side 4 is 1, 3. Goes to 1, 2. Which is, that's wrong. Or that's different than I thought it would be. I thought it'd be 1, 3, 2, 1. 1, 3. But I think I just did the order wrong. Okay. Yeah, because this is 1 to 2. Yeah, 1, 3, and side 1, side 2. And then 0, 2. Is the same as 0, 2. Okay, so that's side 4. This should be the same as counterclockwise on side 2. Which is not... Or side 1, sorry. But I think I flipped it again. So 0 to 2 should be triangle 0 and 2. So let me see here. Which it is, but I got... I think I went around like that. Wait. 0, 2 is the same as 0, 2. Side 2, counterclockwise. 0. Yeah, it should be side 1. Okay. I'm really confusing myself. And then it says, yeah, 0 to 2. Okay, so that's right. And the last one, 0, or 1, 3. is the same as a 1 to 2, which should be the same as side 2. Okay, and it is, thankfully. And then this one is 0 to 2 is the same as 1 to 0, which should be side 2 counterclockwise. Which it's not. 1, 0. It should be down here. Oh, right, side 5. 0, 1, 2. Okay, so counterclockwise 0, 2 is 1, 0. And then clockwise 1, 3 is 1, 2. Okay, yeah. So 2, 0, 2, 1, 0, 0, 2. Oh, it is the same. Okay, this is quite confusing. Okay, so now do I see a pattern? Well, there's... Okay, these are 0, 2, 0, 2, 0, 2, 1, 3, 1, 3, 1, 3, and... Yeah, so those are just kind of flipped. That means that this should be the same. 0, 2, 0, 2, 0, 2, and this should be 0, 2, 0, 2. Okay, something's wrong here. Side 2, counterclockwise. 0 to 2 is the same as 1 to 0, so that's right. Maybe they're not the same, actually. And then side 5, clockwise, 0, 2 is the same as 1, 0. What? What do I keep reading wrong? So 2, 0, 2, 0, 2, 0, 2, 1, 0. Okay, so maybe this is the one that's not following the same pattern. Okay, so counterclockwise here. Side 0, counterclockwise, 0, 2, 2, 0. Okay, so I did that backwards. Okay, so let's see. Does this all match? 0, 1, 1, 2, 1, 2. 0, 1, 1, 2, 1, 2. So it looks like when you go from sides, or from sides 1, 2, or 0, 1, and 2, to sides 3, 4, 5, the clockwise and counterclockwise just trade. So I could probably use that to my advantage. And that makes sense because before I realized that the triangles really only need 6 twin maps. Just the clockwise direction, and it can figure out every other side just by using the counterclockwise on a different hexagon. Because like this clockwise starting from point 0 is the same as counterclockwise point wait. Yeah, it's the same as counterclockwise for this side here. Which is how I've done that before. So maybe I'll work a little backwards here and see if I can do it that way. I think like for our hexagons we did have to have clockwise and counterclockwise because they weren't really mirrored easily. Yeah, because it's not exactly the same. So maybe I'll start on this, at this code first. Okay, so for a rectangle margin, we want to find a triangle that has our same side. Yeah, because we have 2. Okay, so let me see here. The triangle with our same side is our clockwise neighbor. So, okay, I want on the triangle to a rectangle, same side. So I guess, do I need to do orientation here? Actually, I think I do because for rectangles it's different. This will be my clockwise neighbor. Okay, and then here, I already have this, so I can just do that. Oh, except I'm finding the triangle margin. Okay, well this... Okay, so even though a triangle doesn't really need clockwise and counterclockwise neighbors, I think, and... Well, okay, how should I say this? The rectangle only needs... Or the rectangle template only needs to have counterclockwise twin maps to triangles. The triangles need to have both to rectangles because counterclockwise and clockwise are different, have different twin points depending on what side of the rectangle you're on. I think so anyway. Okay, so let me see. I'm not making the same mistake here. So I want to find the triangle that's on my same side, but then the clockwise... Yeah, because this is point... or side 0 for rectangle, side 0 triangle. And then clockwise is that direction, so we're basically finding this edge. But then, so for this edge of the rectangle, we'd want our clockwise neighbor triangle, which is here. And then we want this edge, which is the counterclockwise. Okay, so I think that's good. Okay, and then on the neighbor, I don't need to look for triangles because we only have 2 triangle neighbors and we find both of them there. So here I'm checking... Okay, my entry before me, the counterclockwise neighbor. Let's go ahead and get a reference. So counterclockwise on side on. I can find the O. Okay, and then I'll just copy. So I want the... Oh, we're actually going to look from the rectangle to the triangle, so I want clockwise that way. Okay, so yeah, we want the twin map on the rectangle going to triangle, and we want it on counterclockwise side. And we also want the orientation to be... Well, let's make sure. Okay, so for here, I'd be finding it on this hexagon. I'd find counterclockwise rectangle. And then I want it on the clockwise side of the rectangle, so I did that backwards actually. So in other words, the rectangle margins only need the clockwise orientation for triangles. Okay, so that's... takes care of that. Okay, so let me see. Again, I think I'll just make a function here. Void make rect. I guess I should do triangle to rect because rectangles don't need the counterclockwise direction to rect. Okay, so I noticed here actually that obviously we never use the side 1, 2, right? Oh, wait, we do. Okay, so never mind about that. So I'm trying to figure out... Okay, well I guess we should just pass, again, just the start side. I don't know, maybe, okay. So for here, I'm starting from the rectangle. So yeah, all these numbers are from the rectangle's perspective. So I guess since I did it that way, I'll keep this function like that. So this will be the rectangle side. And then I guess I'll do a bool clockwise. Okay, so here I need make, oh, I did this backwards. So it should be rectangle to try now. And again, I noticed that rectangles only need the clockwise direction, right? Yeah. Okay, so C, and then I guess true. Then we just add twin map. Okay, what's it complaining about? Oh, I see, I didn't rename that function. So this will be to triangle, side C, and then I guess I'll just put clockwise. And we won't do it counterclockwise. And then for triangles, I need to do it both ways though. Okay, when does it clear the twin list? It must, okay, it clears it after you build a twin map. Okay, that's a little, gonna be a little inefficient, but I guess I'll just go with it. Okay, so we're gonna find rectangle to triangle, and then I'm gonna flip the twins. And then, okay, notably here where I'm trying to make it clockwise, I need to register this as counterclockwise because it's actually counterclockwise from the triangle's perspective. As we can see here, this side is clockwise on the rectangle, but counterclockwise on the triangle. Then I'll do the same thing counterclockwise. So yeah, we could make this a little more efficient by, well, really, it'd be better if we made from triangle to rectangle, but yeah, it's not that big of a deal. This only runs once during loading, so it doesn't have to be the most efficient. And it's not like we loop through that much. Alright, so, okay. Pattern here is depending on the side. Okay, well we can just figure out for these, and then if we're past side 3, we would just flip it at the end. Oh, actually, no, we do it at the beginning, so let me see here. If rectangle side is greater than or equal to 3, then we subtract by 3 and flip the clockwise. Not. Okay, and that will give us what we want, because here, yeah, we've, so basically if we want clockwise side 3, we can get the same thing by getting that counterclockwise at side 0, because they have the same values. I guess I'll bring this into the code again. Oh, I don't know why it added those spaces, but whatever. So probably gonna comment this weird. I remember I did that before. Oh, I actually did it right that time. Okay, so pattern here again. So it's counterclockwise as my counterclockwise points. So I guess, let me see, how would I do this? So by definition, the number of points or the number of rows in a rectangle margin is the same as the number of points on a triangle side. Okay, and I can get the number of points on a triangle side by getting the template. Oh, it actually don't need that right there. I think I will need it for this calculation though. Okay, so int num twin. Oh, let's do it this way. Num points on shared edge is the same as a triangle template arrange data 0, which is the number of points on the edge. Okay, and okay, let's see. The try point start is 1 because the center point is always 0, so it's 1 plus num points on shared edge minus 1 because we don't want to count the corner points twice times the start corner for the triangle, which is either okay, which varies. That's interesting. We never start on point 2. Let me make sure that's right. The point 2 is this one. Okay, so it's there, there. Yeah, so we never start on point 2. Okay, that's good. Okay, so let's see. Start on point 0 if... How should I figure this out? At least we know we always start on either left or right side based on if it's clockwise for the rectangle, that is. And triangle side. I think the easiest way is to do it this way. So if clockwise, triangle side equals 0, or it's 0 if we're on side 0. So rect side. Otherwise 1. Also, this is... let's not... Oh, no, that is actually what I want. But this should actually be like the rectangle hexagon side. Not to be confused with the side of the rectangle we're working with. And then if we're counterclockwise, then the triangle side is 1 if we're on side 2, otherwise 0. Okay, so anyway, now that we know that, we can just multiply that right there to give us the start point for the triangles. And so, okay, rect start point. I don't know if this is going to be very useful, actually. Well, maybe. So if it's clockwise, we'll start at 0. Oh wait, no, if it's counterclockwise, we'd start at 0. If it's clockwise, we start at this point, which is the number of points in this, in an even row minus 1. So let me see. Rect num points in even row is rect template arrange data 1, because 0 is a number of even rows, which is the same as the number of points on the shared edge. Also, number of rows in the rectangle. I guess I should just that. Okay, so for clockwise, we start at rect number of points in even row minus 1. Otherwise, we start at 0. Okay, so now I just need to loop through every shared point. So number of P equals 0. Number of points on the shared edge. Oh, I did this backwards. And then... Okay, let me see. So luckily, we always... Okay, thank goodness we never go backwards along the triangle because that would just add another level of complexity. We always go clockwise around the triangle. So let me see. Let me make sure that's true. So clockwise is that... Wait. Okay, that is actually not true. This should be 0 to 2. Did I do that right? I did do that right. Okay, but actually, yeah, 0 to 2. Okay, that's not clockwise, that's counterclockwise. Because I'm skipping the point. Oh, I see. So... then this triangle side is actually just the start point, not the side. Okay. But yeah, when we move backwards, the start point should actually be 2. Okay, so this is a bit more complicated than I did before. Well, not really. So if we're going counterclockwise, I just need to change this. If point is 2, we're on the first... Or wait, this is... Yeah, on the first side because we're going 0 to 1. But I need to flip it. And then here, this is actually on the second. Or the last side. And then this is going 0 to 1. Right ways. Okay, so that's right. And then here we're going right ways around 1 to 2. Okay, well this is good. You can see if we're going clockwise, it's always also clockwise around the triangle. Or point-wise, I guess I should say. But if we're counterclockwise, we're always going backwards around the triangle. That way I don't have to have a separate variable for that. Okay, so anyway, the rect point. So for the rectangle, we're always like moving along the rectangle, so this is a bit simpler. Okay, so it's the number of even points in the row times p, but then for every odd p, we have to add another point, so... it's also rect start point plus p times, and then plus p divided by 2, because we add a point for every odd row. Okay, well in that case I need to do p plus 1 divided by 2 actually. Okay, so at 0 we just do the start point, which I already calculated here. And then for 1 it would be 0 plus that, which... Okay, for this diagram we have 4 points, so it's 0 plus 4, which is that. And then for the p equals 2. Oh wait, okay, this is kind of confusing actually, because if our clockwise are clockwise, we might not add a point. Yeah, because if we're on the clockwise side, we want to add a point when p equals 1 and 3. But if we're going on the counterclockwise side, we want to add a point when p equals 2 and 4. Okay, so I can't do it like this. Okay, this is the most... definitely the most complicated. So let's see. If clockwise rect point plus equals p divided by 2. Do I need to add 1 actually? A p plus 1. Because we want to add 1 on when p equals 1 and 3. So add a point for every odd row. Rect point. We want to add a point for every row when p is greater than 0. So I'll do this else. If p is greater than 0, we'll add a point. Okay, so add a point for every even row after p equals 0. Alright, okay. So that takes care of the rectangle. For triangles, it's not that difficult. It's the triangle point start plus p. Okay, I actually should do it a little differently. Okay, so if it's clockwise, we know that we're winding around the same direction that the points proceed in the triangle, so here it's just tri-point start plus p. Oh, I also... okay, I need to... yeah, we'll need to do a modulo also. Okay, well, that's not that difficult. Actually, it is a bit difficult. Okay, so int num... okay, let's say try num points on border. Oh, come on. So that is just the number of points on the shared edge minus 1 times 3. Okay, and the reason I have to do that is, again, oh, I have to add 1 because of the center point. Okay, let's see this. Okay, so we'll do tri-point start plus okay, I guess I'll just change this. Num points on tri edge. Subtract by 1 and then multiply that by the triangle edge. Okay, let's, I guess, to be consistent, I'll rename this to triangle side. And we have to subtract by 1 because I don't want to count the corners twice. Okay, so we'll do that and then add p, and then I have to modulo by the number of points on the border. Okay, so that's clockwise. Counterclockwise, we count backwards, so we actually start on side plus 1 minus p. And I still need to modulo, so that makes it even more complicated. Okay, so tri-point start plus times tri-side plus 1 minus p. Oh, well, okay, I was thinking, do I need to like add this also so I don't loop back into negative, but that should never happen. Yeah, okay, so that takes care of that, and so now I can just add twin. So we're going from rectangle to triangle. Yeah, so rect point to tri-point. Okay, so clockwise, yeah, we are winding the same direction as points, so that's good, and counterclockwise we're going backwards, so that's why we have to do it this way. That's side 2 and side 0. Alright, so I think that should take care of it. But this is considerably more complicated than the other two twins that we did today, so I wouldn't be surprised if there's an error. Hopefully it'll work nice, looks like be a good way to end the stream. Oh wow, no errors. Okay, well, that's promising. It's smooth there on the border. Okay, well no, it's not working perfectly because well, these are almost exactly equal, but these are not. So somewhere I got something messed up. And also, yeah, this point should never be affected. This try point start should be 1. I'm just gonna need to go and like look and see what's going on here. But fortunately I've got to go grab something to eat, so I'll probably figure out this math that I did wrong off stream and then I'll show it when I start tomorrow. Just because, yeah, I'm just gonna need to do some looking through the logs to see what's wrong. But that's good. We'll be done with pretty much all smoothing. One other thing I want to do, and you can kind of see it here. Well, the lighting is pretty subtle right now, but like the blending is a little strange because the hexagon should be mostly flat. And especially here you can see some weird artifacts like right there. If I change the light so that it's more harsh on the terrain. Yeah, see, that does not look good. It's the shadows, and it shouldn't look like that. So what's the issue is that if I go in the scene, you can see that the hexagons are so large, but the game is blending the normals from this point all the way to the center, when really we really just want the normals to be blended on just a small area. So what I have to do is add another ring of points here that will blend only the normals between those points, and otherwise it'll just be straight up, so this area will still look flat. And that should make it look a lot better. Because, well, again, we'll have smooth lighting across the borders, but we won't get weird things where there's a shadow only in the middle of the terrain, for example. But yeah, I think yeah, I'm glad we got a lot done today, and finally almost done with this normal smoothing, which ironically was pretty much the main reason why I started rewriting the terrain. So hopefully tomorrow I'll finally be able to work on some more art and we'll get some actual good looking textures, I hope. And after terrain, what's next on the list? Still got quite a bit to do here. This is kind of part... Okay, so this was before I added in the UV maps, so I might not need to even do that anymore. Maybe we'll switch to some gameplay and I'll implement some other actions that need to be done. Also, oh, the camera should really be updated. Maybe I'll do that. Also, there finally Unity... I don't think it's even officially released yet, but it's like not in beta anymore. But Unity 2018 came out, so at some point I need to make sure that the game still runs with that, so we'll be doing that soon. And that will also have lots of upgrades, including the new render pipeline, which I'm really excited about. I don't really know when I'll use it in this game, but I'm sure I'll update it at some point. But anyway, yeah, I've got to get going, so thanks everybody for coming by and watching. I really appreciate it. I had quite a bit of people today, so that makes me feel good. If you want to follow me here on Twitch, I of course, appreciate it. You'll be notified when I go live around tomorrow at noon. I also will post on my Twitter, so you can follow me there if you want to. I have a YouTube channel where I upload all my streams if you'd like to catch up on any you might have missed. And finally, I have a Discord server where I'd love to chat with you throughout the day. It'd be great to have you. And I'll put links in chat, or you can check out my video description if you're on YouTube. And yeah, I think that's about it. So yeah, I hope you all have a great day, and I'll see you tomorrow. Bye-bye.